All right, we will start here in a few seconds. So just a quick announcement, we will have a quiz, our first quiz on Friday, June 18th. It will be 30 minutes, and the quiz will open at 10:15. So we'll be having a class from 9:45 up to 10:15, and then the quiz will close at 11:15. So it will be a 1 hour interval, and you are allowed to have only one attempt. And you can attempt in any 30 minutes and in between 10:15 up to 11:15. So you can do 10:15 to 10:45, or you can do 10:30 to 11. So whatever works for you. So it will open only for 1 hour. You will access the quiz through Canvas. So you basically come here, and then you should be find the quiz on Module. So I will post, let's go. Yeah, so this you should be access the quiz one, and it's multiple choice, but there will be some questions that will require you to have a paper and pen so you can solve and do some equation analysis and get some results. So you should have the equation sheets. So I just posted the dynamics full equation sheet, so you are allowed to use this sheet or use my notes or whatever. So that's the only thing that you are allowed to use, and you can use your calculator. So and then you will be good to go with the quiz. So let's roll here for our third lecture, and this is the announcement here. If somebody came late and want to see the announcement. Okay, so over the last two lectures, we have been dealing with motion on a straight line. So this is our straight road, and there's a car here. It started at this origin and made this distance. So this is a straight line. However, this motion is not the only motion that we have. We have multiple types of motion. And so, yeah, I forget to get the mic. So what if this car moved first on a straight line and then had to take a curve? So it had to do some curvilinear motion. So what will be the case? How can we solve this problem? So our equations from previous rectilinear motion cannot work with curvilinear motion, but it's kind of similar, and we will see in a few minutes how similar it is. So for curvilinear path, so if we have the path like this, and our car started here, or let's like this, and our car started somewhere here and ended somewhere here, and let's say that this is the origin. So the car made a distance from here up to here. Let's call it S1, and the second one, this, let's call it S2. But if we want to measure the position, so we need an origin to measure this position. Usually the origin for the curvilinear motion, that means that the particle moving along a curved path. So usually the origin is the center of curvature, or the center of the circle, or an origin for an XY coordinate system. So let's assume that this is the origin that we measure the motion from. So the particle, so this is the position vector from this origin. So let's call this R vector. from this origin O, and this is the position of the second location of the particle, and let's call this R dash. So we measure the position of the particle on this curved path from this origin. All right, so let's define our motion. So we define the motion first with the position. So for the position, we use our vector, and our vector could be in 2D or could be in 3D. So if the motion is in 3D, so it will be 3D. But in our dynamic class, we will be only focused on 2D motion. And as you know from vector algebra, you know that the vector R has a magnitude and direction. So you should be able to get both of them, and we will see how can we get them. So this is for the position. Let's go to the second thing. So for the position, you have R vector and you have R dash vector. So this is how we describe the position on this curved path. So let's see how can we use R vector and R dash vector to get the displacement of the particle. So displacement. So the displacement, we name it delta R, and it's still a vector quantity. And delta R is the final position of the particle. So this is the final position, R vector dash minus R vector. So this is the displacement, which is the change in the position of the particle. So here it ended here, and this is the initial position. So this is for the displacement. So let's get to the third one, which is the distance traveled. So for the distance traveled, I don't care about the position. So this, like if we have, like, let's make it in red. So this, from vector algebra, this is delta R. So based on your past knowledge, you have this vector R. Like if you put R vector plus delta R vector should be equal to R dash vector. So delta R will be equal to R dash minus R. So this is the change in the position. So let's see what is the distance traveled from point 1 up to point 2. So the distance traveled is the distance that you did on this curved path. So it should be S2 minus S1. So it should be, let's call this delta S. So delta S is the distance traveled, which will be equal to S2 minus S1, which is the distances on the curved path itself. So let's get to the second thing, which is the velocity. So let's get here to velocity. So for the velocity, we have different types of velocities, like different definitions. Let's see the first one, which is the average velocity. So for the average velocity, so it will be equal to, let's say, V average. It will be equal to the displacement of the particle, delta R vector, over the total time, delta T. So this is, it's a similar to the 1D, but here we have it rather than delta S, it's delta R, because delta S now is the distance on the curved path. But delta R is the shortest distance, or the linear distance, between position 1 and position 2. Okay, let's get to the second one, which is the instantaneous velocity. So instantaneous velocity, we need to know the velocity of the particle at each position, here or here or here. So it should be v will be equal d r vector dt. So, or as we learned it from last time, we can write it as r dot. So this is how we define our instantaneous velocity. So it's the time rate of a change of the position, or the diverse derivative of the position vector. Let's get to the third one, which is the average speed. So the average speed from last time, which will be equal to the total distance traveled, which will be delta S. So the position is defined by delta R, like the change in the position. But when we're talking about speed, we need the total distance on this curved path, which is delta S. So it will be delta S over delta T. And let's get to the instantaneous speed. Like if we want the speed of the car at any point on this curved path. For instantaneous speed, instantaneous speed is ds dt, is the time rate of a change of the speed over this curved path. So this is the difference between the different terminologies of the velocity, and we will be using this one actually in most all of the cases, but you have to know the other ones. So let's get to the acceleration. So for the acceleration, let's get number one, which is the average acceleration. So for the average acceleration, let's assume that this is our path, and here is the position 1 for our particle, and this is the position 2 of our particle. So always the velocity is always tangential to the curved path. So this should be v1, and this should be v2. So the velocity in all the cases, in all the linear or curvilinear motion, so the velocity is always tangential to the path of motion. So we have v1 here and we have v2 here. So the average acceleration is equal to average is equal to v2 vector minus v1 as a vector over the delta time t. And it's still a vector quantity. So the A average is vector quantity, and also the v here is a vector quantity, and also the v average is a vector quantity. The speed is a scalar, and the average speed and the speed are scalar quantities. So here, A average is vector quantity. So let's get to the second one, instantaneous acceleration. So the instantaneous acceleration, which is defined by A, and it's still a vector quantity, it's the time rate of change of the velocity. We can write it as a v dot or r double dot, the double derivative of the position vector. So this is most of the equations, and we will mostly use this one. But sometimes you might be asked for the average acceleration, so you will have to know the velocity where the particles start and the velocity at the particle end in terms of vectors, and then subtract the final velocity minus the initial velocity and divide them over t. So with this will take us to the next section in our chapter, chapter 12.5, Cartesian curvilinear motion. So we can describe the position, like let's get okay, and let's say that here is the start, and here's the end, here's 1, and here's 2. So we can describe the position and the velocity and the acceleration at 1 and 2 using different coordinate systems. So our first coordinate system is Cartesian coordinate system, which is x and y. We can describe it using tangent normal coordinate system. We call it T and N. And number 3 is the polar coordinate system, which is R and theta. So we can use any of these systems. And we will be discussing today this, which is in chapter 12.5, and this is a chapter 12.17. This is chapter 12.18, I think so. So let's start today with the Cartesian curvilinear motion and how can we describe this motion. So all right. So let's describe this motion, the one that I just wrote, using an XY coordinate system. Let's assume that our XY coordinate system is somewhere here. So this is Y, and this is, sorry, this is X. This is Y. And let's describe this motion. So at position 1, we will be drawing the R vector, the position vector, from this location. And we will be calling this as the R vector. So let's make it general without any, so let's call this as R vector. So the R could be analyzed and projected on its XY axis. So this be Ry, and this will be Rx, and we can write R vector as Rx in the direction of X, which we call it I hat, plus Ry in the direction of Y, which is J hat. So the J hat is the unit vector in the Y direction. So this unit vector is called J hat, and this is unit vector is called I hat. So this is the magnitude of R in X direction, and this is the direction in X axis. This is the magnitude of the R in Y axis, and the direction is J hat. So we can write it any vector like this in I and J. And I suppose, like, you know these things from physics, how we can deal with vector algebra. And for the velocity, so let's, as I told you from before, that the velocity is always tangential to the path. So let's say that this is V, and also V could be written into Vx and Vy. So the V vector can be written as Vx, which is the magnitude in the X direction, and here's in the the direction of x and I hat plus vy and j hat. And let's the other component, which is the acceleration. So let's assume that the the acceleration in this direction. So this is a, and I forget the vector over a v. And let's see the x component of a. So the x component of a is like this, and the y component of a is like this. So this is ax and this is ay. So we can write the acceleration as ax in the direction of I plus ay in the direction of j. So this is how we write the components of the position, velocity, and acceleration in x and y direction. And this is the Cartesian components of these kinematic component, like position, velocity, and acceleration. So let's see a quick example. How can we solve problems that has components in x and y direction? So let's pick an example. Let's pick this example.
Hey, Professor, I had a quick question.
Yeah, sure. Go ahead.
I saw that we have a quiz this Friday, but I was wondering, I think you said earlier that normally they're on Wednesdays, so in the future they're going to be on Wednesdays during the class period?
Oh yeah, but I think it shouldn't have like a regular time to have the quiz. It depends on like the homework time as submission, but we might think about, do you guys want to like have a fixed day for the quizzes? We might like make a survey. If we need a fixed day, we might set up this day.
Yeah, because I was curious if it's a fixed day, is it going to be taken during class periods? Is that the only time we're going to be able to take it?
Yeah, so I have the first 30 minutes of the class, like on Friday. We will start our class at 9:45, and we will end our class like at 10:10, and you will be good to start your quiz after 5 minutes at 10:15 and end it at the class time, which is 10:45. If somebody wants to start the quiz after that time, so he can start the quiz. So you will have the first 30 minutes during the class time, but if you want to do it outside the class time after 30 minutes, so you can do that.
Okay, because right now I'm being scheduled for work during like class time a lot of the time.
Okay.
I'm actually on break right now, but I was just wondering in the future, if we have a scheduled day, I can ask for that day off for the mornings. That way I can schedule so I can take the quizzes.
Okay, yeah, that sounds good, but it's still.
I agree. Yeah, having a fixed day on the quiz would definitely be helpful.
Okay, yeah. So, yeah. So it's still during the class time. So you guys like want me to make a survey and make a fixed time for the quizzes? Or,
yeah, that would be great.
Okay, so yeah, I might do it from the next time, and I will send you guys a Google survey and put some dates for these, and check like what is your preferences.
All right, thank you.
Thanks. All right, so let's get back to the this one. Okay, this one. Copy. So this is our first problem on the curvilinear motion. So it says that at any instant, the horizontal position of this weather balloon is defined by x equal 8 times t, and it's in foot, and where t is in seconds. If the equation of the path is equal to y equal x squared over 10, determine the magnitude and the direction of the velocity and acceleration at 2 seconds. So let's see how we can solve this problem. So let's put the given equation. So it says that x is equal to 8t and y is equal to x squared over 10. So you can get the, so y now is a function of x, so we can get it as a function of t. So by substitute this value, so it will be 64t squared over 10, so it will be 6.4 t squared, and it's still on foot. All right, so right now, I can write the position vector as a function of, like we have Rx, we can call it X. So whatever is best for you, you can call it X or Rx, and we can keep it as Y. So if we need to get the velocity, so let's number one. So as you know from this equation, the velocity should have two components. One is Fx and the other one is Fy. So we need to find both. So Vx will be equal to dx dt. So you will have to differentiate this. It will give you 8. So it's a constant velocity. And Vy is dy dt. And this should give you 2 multiplied by 6.4. And this will be t. So it will be 12.8 t. So this is y's function of t, but what is required in the problem is to find the velocity at t seconds. So here's constant. So it doesn't matter whatever the time it is, it will be still 8 feet per second. But for Vy, times matter, so t equal 2, so we'll have 12.8 multiplied by 2, should give you 25.6. So this is the Vy, and this is feet per second. And you can write the final V vector. So all of these are magnitudes, and we know that x is in I hat and y is in j hat, which is the unit vector in x direction. And this is the unit vector for the y direction. So it will be 8 in the direction of I hat, plus, let's keep it with respect to t, it will be 12.8t in the direction of j hat. But for v vector at t equal 2 seconds, so it will be 8 I hat plus 25.6 in j hat. So this is the vector quantity of the velocity. But whenever you are asked about the magnitude and direction, so you will have to get the magnitude of this vector and the direction of this vector. So let's get them. So the magnitude of v will be equal to, you will use the Pythagorean theory. So you will have 8 here, and you will have 25.6 here, and it should be, so this is Vx, and this is Vy, and this should be the vector of V, like this. So we need the magnitude of this vector, which will be equal to 8 squared plus 25.6 squared. This will give you 26.82 feet per second as the magnitude of this vector. And if you want to get the angle theta with the horizontal of this vector, so you will say that theta will be equal tan inverse the y component, which is the 25.6 over the x component, which will be 8, because this is the y component and this is the x component. So the tan of this angle is the y over the x component. And the angle will be 72.64. So this is, so we can like make it like this, and this the velocity, and this is our angle theta, and it's 72.64. So this is the magnitude and the direction of the velocity. So let's get to the second part, which is the acceleration. So for the acceleration, we need to do the same thing. We need to get AX. So EX is dVx dt. So if you differentiate this constant, which is 8, will give you 0 acceleration in x direction. AY is dVy by dt. And here is a 12.8t. So if you differentiate this, it will give you 12.8, which is a constant acceleration. So this will give you a vector quantity of the acceleration 0 in I direction, which means x direction, plus 12.8 in j hat. So that means like the total value of the acceleration is in y direction. So there's no x direction. So the magnitude A, if you get the sum of squares, it will still give you 12.8 feet per second square. And the theta, if you calculate the theta, use tan inverse the y component over the x component, it should give you a 90 degree. And also you still know that all the acceleration is in y direction, which means the angle is 90 degree. So if you want to put this on the this figure, so the velocity should be tangent here at 2 seconds. So this should be the v vector, and the acceleration is vertical in this direction. So this is a vector. That means that the balloon only have an acceleration in y-axis. That means it's going up. It doesn't like move, but this is the velocity direction of this balloon. So this is just a quick example, just like you are solving a rectilinear problem, but you are solving in x and y and put them in a vector component, so you can construct, you can solve for these vectors. Okay, so this will take us to the next section in our class today, which is the projectile motion. So projectile motion is one of the application of the Cartesian coordinate system. So like assume that this is the x-axis and this is the y-axis, and you have like a soccer ball at this location, and you kick it, the soccer ball to move on this projectile, like it goes like this until it gets here. So you give the soccer ball a v node at this location, and it has a velocity like this in this location. So this is the v node x vx node, and this is the vy node, and here is the vx at this position, and this is the vy at this position, and you can get the velocity at any of these positions. So the most important thing about projectiles, it's under the projectile is moving under its own weight if we neglect the wind resistance or the air resistance. So it's only moving under its weight. So the acceleration affecting this particle is the gravity acceleration, and it's always down, and it's equal to g and negative g because it's down, and my y-axis is up, and it's equal 9.81 meter per second square, or it's equal to negative 32.2 feet per second square. So this is the most important thing about projectile motion. So if you recall from the last time that we have some equations in the dynamic equation sheet, and you are good to use them in your exams or whatever. So, and we derived these equations from versed principles last time, the general one and the non-constant one and the constant one. And for the projectile motion, it's under constant acceleration, which is the gravitational acceleration. And this is good unless in the problem say that there is other type of acceleration that affecting this projectile motion, like a body in the space, that there's no gravitational acceleration, and there's some other types of acceleration, so you will have to neglect what I'm telling you right now. But most all of the projectile motion, you can use this set of equations because they are under constant acceleration, and a node is equal to negative 9.81. So let's put these equations in front of us. So this is S minus S node is equal to V node T minus T node plus half, and have the acceleration, which a constant, multiplied by T minus T node square. The second equation that we have is V minus V node is equal to the constant acceleration multiplied by T minus T node. And the final one, which is the V square minus V node square, will be equal to a constant multiplied by S minus S node. So these are the three equations, and you should like replace the A constant by negative 9.81. Depends on the problem if it's in feet, so you will have to put negative 32.2. So this is for the projectile motion. And this is for the linear form. So you should be writing this in like, analyze this in X and Y direction. So let's see how this look like if we did a horizontal motion and the vertical motion of the projectile. Let's see how is the X direction of the motion look like and the Y direction of the motion look like. So let's get to one, the horizontal motion of the projectile. So there is no acceleration in X direction, but there's one in Y direction. So the horizontal direction, the EX is equal to 0. So it's constant, but it's equal to 0. So this will give you the, if you solve it, like let's do this first. So Vx minus Vx node will be equal to, the acceleration is 0, so all this term will be 0. So this means that Vx equal Vx node. And if you try to substitute in this and the acceleration will be 0, that means that V square equal V node square, Vx square equal Vx node square. And finally, it will end up with the same equation. Let's substitute in the S. So that means like we have X minus X node will be equal to Vx node. Substitute in this, T minus T node. And if you come here, it will be minus 1.5 multiplied by G, which is 9.81. Oh, sorry, it should be, this is 0. Like I'm still in the horizontal, so the acceleration here is 0, so it's only be in this format. So because the acceleration, I'm still solving for horizontal motion, so X minus X node equal to Vx node multiplied by T minus T node. But when we come to the vertical component of the motion, and we know that AY is equal to negative G, which is 9.81 meter per second square. And solving, writing the same equations, so it will end up with like you will have that Vy minus Vy node, if you substitute here, will give you negative g multiplied by t minus t naught. And you can have y. Let's substitute here. So it will give you y minus y naught will be equal to vy naught t minus t naught plus half multiplied by negative g and multiplied here by t minus t naught all squared. So you might like remove the negative from here and put it here, whatever it works for you. And the last one, which is the vy square minus vy naught square, will be equal to negative 2 multiplied by g, and here multiplied by y minus y naught. So what we did, just like we wrote these equations in the horizontal and vertical motion, and we can solve the x direction separately from the y direction. So let's see an example how we can apply this on a real example. So let's get this example. Okay. Okay. Okay, this example is saying that there's a sack slides on this slider, on this ramp, and with a horizontal velocity. So this is the horizontal velocity is 12 meters per second. And if the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor. So he needs the time where the sack came here. And the range R where the sacks begin to pile up. So it needs these two things. So first thing, you will have to write this equation, like write this Vy or Vx equation. So you will have to do this first and determine what do you have right now, what is required, and what is the things that you have. You have Vx node, so here's the Vx node. And if you look at here, and you don't have the time, so you cannot like start solving this problem, but you can solve this. You can solve that the Vx node will be the Vx at here using this equation. And after solving this equation, you can come here and like, you know, the x. So here's the xy axis that you have. So the start here at x equals 0, and the x here is equal r. So you know the let's start like solving in x direction first for x direction. And for x direction, if you apply these set of equations, you will end up with like Vx, and you have, for this one, you have Vx node is equal to 12 meter per second. And here you have V equal Vx node, which is equal to 12 meter per second. If you solve the second one and put x minus x node equal to Vx node multiplied by t minus t node, so t node is equal to 0 starting from rest at here. So you will end up with like, let's do the same color. So x node here is 0, and t node here is 0, and so this, and x is equal to r, this location. So you will have R will be equal to the Vx node 12 multiplied by T. So here we have two unknowns, which is the required one, the range R and the time, determine the time T. So we cannot solve this right now. So we will have to go to the Y direction so we can get some unknowns. So for Y direction, so let's just start solve for Y direction. So for Y direction, we know the Y node is equal to, let's make it red. Y node is equal to 0 because here's our X and Y axis. And we know the final Y of the stack here is equal to 6 meters. So we know a Y and Y node and Vy node, and we know the G, and actually the Vy node. So all the SAC start with a V node in X directions. There wasn't any components in Y direction. So we know that Vy node is equal to 0. And knowing Y and Y node, and you know the G 9.81, and you know that T node is equal to 0, so you can solve for T. So let's put this equation here. So Y minus Y node will be equal to Vy node. So we know from here that Vy node is equal to 0 because all the velocity component is in X direction. T minus T node 1 over 2 multiplied by 9.81 multiplied by T squared. So here Y node is 0, Vy node is 0, and Y node here is 0, and we know Y is equal to 6. So this will be, yeah. So here is not 6 because the Y direction positive is there, and this should be negative. I knew that because I have here is T squared, and this should be negative, so this negative could go with this negative. So, but you should know from verse that this is Y node, the final Y is equal to negative 6 because this is down there below the x-axis. So negative 6 will be equal to negative 1 over 2 multiplied by 9.81 and multiplied by T squared. So this will end, you can get that T. After you solve this problem, it will be 1.11 second. So just multiply 2 by 6 and divide by 9.81 and take the root. So it will give you T 1.11 second. And if we want to get the R, so we can get back to this equation and say that R will be equal to 12 multiplied by 1.11. And it will give you that R will be 13.27 meter. So this is the second requirement. So what I would do to solve this problem from verse, actually, I would write these equations in front of me and know what is known and what is unknown. So like I know that the Y direction will not do anything for me because I mean like the velocity in the Y direction, because I know that Vy node is equal to 0 and the Vy will be, I don't know the Vy here, so it's stopped, so I can't use this equation. But for this equation, I know the Y, I know Y node, I know that Vy node is equal to 0, and it will, and I know G, so it will give you the time T. So this will allow you to solve the problem from here and get T, and then after you get T, you will think about the other direction. So you will have that the required is R here, and you have X node is equal to 0, and you have X node given, and then finally you got T from the other equation, so you can solve from R here. So this is for this problem. So let's try another one, a very quick one. So how about, let's do this one. Okay. Copy. paste. Okay, in this problem, it says that this shipping machine, wood shipping machine, is designed to eject wood with this angle, and it gives you the V node. So right now, as you can see, the V node has inclination on the x-axis, which means you will have a V node in x direction and V node x and V node y. So you will have components in x and y direction, and which makes us think about this equation, like whatever, like we have Vy node, or you have the Vx node. So let's copy. Yep, and if the tube is oriented at 30 degrees from the horizontal, determine the height h, like this height of the stack, and determine how high h the ships can strike the pile if at an instant they land on the pile at 20 feet distance. So it gives you the final x. So you know that x-axis and y-axis is here. So you know that x node and y node is 0 at this location, which is the initial one. And you know the final x here. So you know the x node and the final x, but you don't know the y. So this will make us think about this equation, x minus x node. So let's copy this equation. Paste. So if you look at this equation, you can directly get the time that this the wood chip can hit the ground. So let's solve for this. So you have x is equal to 20 foot, and you have x node is equal to 0, and you have the v node with angle, so we can get the vx node. So the vx node will be equal to v node, let's say 25 cosine 30, and then t minus t node, assuming that it starts from t node 0 at this location. So you can get t will be equal to 20 over 25 cosine 30. Solving this will give you that time will be equal to 0.924 seconds. So this is the time where the chip should hit at this location. And the second thing, like this is the time when at this position on the curve. So let's get the h. So to get the h, it means like we will have to deal with y direction. So we need to know what we have in y direction. So we have, let's put the equation, y minus y node will be equal. So let's be organized here. So next direction. And here's in y direction. And here's our equation for y minus y node will be equal to vy node t minus, let's copy the equation. Not this one. Okay, let's write it, it will be more faster. G minus t node square. Let's make sure that we got it right. And then if you want to solve for this, so let's see what we have here. So the y node is 0. So let's see what is the y at this location. So the y, it should be negative, and it should be 4 minus h. So it's negative 4 minus h should be equal to the Vy node. So the Vy node is equal to V node sine 30. So it will be 25 sine 30. And we know the time from here, it will be 0.924 minus 0. And here's minus half multiplied by 9. And the t is 0.924 minus 0 squared. So the only unknown in this equation is h. So you can't solve this simple problem. Just take care about the signs of the g. So you put g here is actually it's on foot, so it will be 32.2. And you will finally end up with h will be equal to 1.8 foot. So that means that here's the point h, which is 1.8 foot. So this is the solution of this problem. Does anybody have any questions on this problem or the other problem? We solved it on the projectile motion. So it's basically, you just have to put these equations in front of you in x direction and y direction and see what given you in the problem and which one you should try first. So you might like start to try this. If you tried other equations, it might give you the final answer in terms of unknowns, like what we did here. It gives us that r is in terms of t. There is no problem. You will go to the other direction to get the time t and then substitute in the first equation. So there's no problem, but it's more efficient that you start to solve the equations with less unknowns so you can get answers and then use these answers to solve other equations. So this is basically how we solve projectile motion. And tomorrow we will be continuing our curvilinear motion using tangent normal. And it's kind of different from the XY. We will be dealing with different coordinate system. And after tomorrow, I will be assigning the second homework, which will be due to Monday. Based on the things that we talked today and also the tomorrow lecture, and you will be good to go. So please, I assigned here in the modules, I assigned a learning exercise here. Try to solve it by today, just like one simple problem on erratic motion. So just like try to solve it. Most of the learning exercise doesn't take more than like 10 minutes to solve them, just like multiple choice. And also the quiz will be multiple choice. So everything we will have, it will be multiple choice. So it will be easy for us to grade the things, specifically with online exams and online homeworks. So that's all for today. If you have any questions, you can go ahead and ask it. All right, so with that, see you guys tomorrow.
See you tomorrow.
See you.
Thank you.